overall in the world population is growing and everybody wants to have a better life, that tends to increase energy consumption. But then at the same time, climate change is a fact. We need to find ways to lower greenhouse gas emissions, and we need to find ways how we replace use of fossil fuels and as both as a source of energy, but also as raw materials for chemicals. Second or third big change is also then urbanization. In some years' time, then roughly 80% of world's population will be living in cities or urban areas. So people are going to be much more tightly packed, which sets its own both challenges, but also brings opportunities in terms of both creating energy, but then also what type of energy is needed. The current business models are still prevalent, and of course kind of like then that the generating the base load and these kinds of things happen still very much like before, but the sort of bringing smartness to energy and especially to the energy consumption and efficient use of energy brings new possibilities, both in terms of then that consumers can be producers, but also in terms of then that how you can yourself as a user of energy then be aware of the cause and effect of what you're doing, how it affects the energy consumption, but also then in a sense by using, for example, gamification and these types of things, then that making it much more attractive for people to be considering how to change their behavior so then that they reduce energy consumption. And that way, of course, then that the business model is changing, but also then that way we achieve the primary goal from the government's point of view is then that we can meet our COP21 goals. Our role is, of course, to try to find solutions then to some of these challenges that are being posed. We have currently roughly 500 people working in the energy area, and our approach is try to be covering basically the whole area of energy in a very, very broad definition of the word. So we are both doing research in the use of energy, we're doing research in the production of energy, and in the distribution of energy. In the use side, we are working with concepts like smart traffic or smart cities and also advanced manufacturing technologies that are more energy efficient, for example. In the production side, our focus is obviously on clean energy. So we have a lot of expertise in solar and wind, bioenergy, safe use of nuclear energy, and then on the distribution side, both in terms of looking at smart grids and these types of concepts, but also then at the societal level, looking at how the energy system as a whole works, what type of energy mix is required for a nation, and also how to run the energy markets. And as a sort of a icing on the cake, then we, like the rest of the country, has a lot of experience on ICT, and digitalization is a trend that is also changing now how the energy markets work, and what are the opportunities then to create, for example, much more energy efficient solutions. So solar and wind are, of course, extremely important in the energy mix. In Finland, we have a very wide variety of ways of generating energy, and solar and wind is now an increasing part of our energy mix. We, of course, are researching the sort of same type of topics as everybody else in terms of solar and wind, that if you look at the key issues that are actually there, how to store solar and wind energy is an important factor, because the whole way of using the energy system changes with the introduction of solar and wind, because it's very, very seasonal, or you can't predict necessarily that well in advance when to have the supply to match then the demand. Second thing is also then that this affects the whole working of the energy system as a whole, energy markets and the economics around that one. But I could also tell a couple of examples, concrete examples around novel ways of using solar energy. One is related to storing the energy. So when the electricity is created either through solar or wind, many times it is much more beneficial than to store it somehow. There's a lot of research being put into battery technologies and these types of things. We have a project going on around storing the electricity in the form of hydrogen gas. So basically using fuel cells as a technology and electrolysis, high temperature electrolysis, then to in a very efficient way then use electricity to break down water into hydrogen and oxygen, so then that we can then store the electricity in the form of hydrogen. And the beauty of this thing, we call it RESOC in the project, is then that we can use the same equipment then and run it the other way around in reverse, then to use hydrogen and oxygen then to generate electricity. So basically you store the electricity and then you regenerate it using the same system. The other one is then that what we're doing together with Lappeenranta University of Technology is that we basically need only sun, water and air to generate either liquid or gas fuel that can be then used in for example cars or commercial vehicles. And the basic idea is then that the running a process then that where with solar panels we capture energy and then use that then to produce from water and carbon dioxide which is in the air, then methane that can be then further synthesized into fuels or chemicals for the chemical industry. VTT can help bringing ideas into real innovations, and with innovations in this context is meant then that it's something which both has novelty as an idea, but it also has commercial use which has been deployed into real life. And that's the key role for VTT, and that's how we are also a tool for the government to implement some of the policies, then to apply research, then to mature ideas, scale them up into industrial scale. One thing which is many times I think forgotten is then that even if you have an idea that something works in a lab, it works in a beaker, it takes quite a lot of work and ingenuity also then to scale something which is at the beaker level, lab tube level, into industrial factory level. And that requires a lot of scientific and engineering knowledge. And that's kind of like then that how the government can accelerate then that the things are put into use by utilizing VTT and other similar organizations then to speed up the development and making it very easy for companies to take new technology into use, and also then that we are able to transfer our competencies then to the companies, so then that they also help learn new things which they haven't had in the past. I think that there is a lot that every country can learn from each other. In Finland, I think that we've been tackling with the sort of the energy mix for a long time. So I think that we have a very wide base for using different technologies to generate our energy. We are at the forefront in many areas in renewable bioenergy. district heating and cooling, combined heat and energy creation, heat and power generation, and also in combining digitalization with the with energy creation and smart grids. Also, I think then that the in the field of nuclear energy, Finland has a very good focus on safe use and generation of nuclear energy. So that's also one of the areas that where we've been paying a lot of attention to.